Hello everyone and welcome to our webinar on external attack surface for initial access in AWS Cloud. I'm Nandini Bharadwaj, the operating officer at CyberWarFare Labs and the host of today's webinar. And I'm really excited to have you all here with us today. So let's get started. Before we jump on the main topic, let me give you a brief about our company. CyberWarFare Labs is a UK-based edtech company. The company is committed to addressing cybersecurity challenges with real-time hands-on solution, and our virtual platform allow users to refine their skills to plug and play practical labs. And so our company has mainly two divisions. The first is Cyber Range Lab. So this division focuses on providing practical real-time solution to cybersecurity challenges, and our platform offers a virtual platform where user can engage in hands-on trainings through practical and theme-based labs that are ready to use. And the second one is upskilling platform. So CW Labs offer a wide range of on-demand courses in red team, blue team, purple team, and cloud security domain, designed for individual at all skills level, that is starting from beginner to intermediate to advanced level. And our instructor-led trainings are available to educational institute, government agencies, and corporate organization. Both online and offline training options are available. To explore more, please drop a mail to our support team, support@cyberwarfare.life. Let's move on to next slide. Okay, so now let's take a moment to introduce our speaker of today's webinar, Parth Agrawal. Parth is a dedicated security intern here at CyberWarFare Labs, bringing a wealth of knowledge and a passion for cloud security to our team. With a strong interest in complexities of cloud services provided by AWS, Azure, and GCP, Parth possesses a deep understanding of these platforms. And as a cloud security enthusiast, Path insights and experience are sure to enrich our discussion today. That's all about the speaker. And dear participants, as promised, we are excited to share that you will receive your attendance certificate within next 48 hours along with a video recording of the webinar. But wait, there is more. 5 lucky winners will have the opportunity to win the access of our latest launch certification and a bestseller, that is Multi-Cloud Red Team Analyst Certification MCRT course. And the winner will be announced shortly after the webinar, so stay tuned for that. And yeah, thank you for being part of this engaging session. We will look forward for your continuous participation. Here, without further ado, I would like Parth to take over and let's get started. Over to you, Parth.
Thank you, Nandini ma'am, for the introduction. Hello, everyone. As ma'am has mentioned, today's focus is on external attack surface for initial access in AWS Cloud. So as you can see on the screen, this is our today's agenda. Firstly, we covered all the services offered by the AWS, followed by an exploration of public URLs associated with some of these services. You can see here. Uh, the public URLs typically have common structures with slight variations in their fields. Finally, we delve into our reconnaissance part, where we learn techniques to gather information and perform reconnaissance on AWS services. We have also allocated time for Q&A session at the end of the webinar. If you have any queries or questions, please feel free to ask. So today we will be exploring various methods for conducting reconnaissance on AWS services. We will explore reconnaissance strategies for a range of AWS services, as you can see here. We will also explore various tools as well. So let's start by knowing the services offered by the AWS. So first on our deck we have EC2 service, which stands for Elastic Compute Cloud. EC2 is a web service provided by the AWS that allows users to rent virtual servers called instances to run applications and services. It enables users to rent virtual servers, providing scalable compute capacity in the cloud. It also offers flexibility in terms of computing power, storage, networking options, making it suitable for a wide range of use cases, from simple web hosting to complex data processing tasks. OS for EC2 instance is known as AMI, which is Amazon Machine Image. So AMI is a template that contains the software configuration required to launch an EC2 instance in the AWS. So next, let's move on to the next service, which is S3, stands for Simple Storage Service. So S3 is a scalable object storage service provided by the AWS that allows users to store and retrieve data over the internet. S3 is designed to provide highly durable and available storage infrastructures for a wide variety of use cases, including data backup and archival, content distribution, application data storage, and data leaks. It also offers features such as unlimited storage capacity, high availability, low latency access to stored data. Next, on our deck, we have EBS, Elastic Block Store. So, Elastic Block Store is a block storage service provided by AWS only that allows users to create persistent block storage volumes for use with Amazon EC2 instances. EBS volumes are highly available and reliable, offering consistent low latency performance. Users can attach and detach EBS volumes to EC2 instance as needed, allowing for flexible storage configurations. EBS volumes support features such as snapshot, encryption, replication, making them suitable for a wide range of use cases, including data storage, application data storage, and file system storages. Next service we have is RDS, Relational Database Service. So RDS is a managed database service that allows users to set up, operate, and scale relatable databases in the cloud. RDS supports various database engines, including MySQL, PostgreSQL, MariaDB, Oracle, and Microsoft SQL Server, and many more. With RDS, user can deploy and manage relational databases without the need to handle the underlying infrastructure tasks such as hardware provisioning, database setup, patching, backups, and monitoring. Our next service is ELB, Elastic Load Balancing. It is a service provided by Amazon that automatically distributes incoming application traffic across EC2 instances, containers, or IP addresses in multiple availability zones within a region. ELB helps improve the availability and fault tolerance of applications by spreading incoming traffic across multiple targets, thereby reducing the risk of overloading any single instance. It also enhances the scalability of applications by automatically scaling the load balancer in response to changes in traffic patterns. It integrates seamlessly with other AWS services such as autoscaling, Route 53, AWS Certificate Manager to provide a comprehensive solution for managing application traffic and ensuring high availability and scalability. Let's move on to the next service, which is AWS Cognito. So it is a fully managed authentication, authorization, and user management services. It enables developers to add user sign up, sign in, and access control to their web and mobile applications quickly and very securely. AWS Cognito simplifies the implementation of authentication, user management in mobile applications, freeing the developers to focus on building core application features. Here in Cognito, we have two main components. One is user pool, which is the directory of user information, and second we have identity pool, which is acts as an access manager for different AWS resource access. Next service we have is CloudFront. So Amazon CloudFront is a content delivery network service provided by AWS only. It accelerates the delivery of web content to users around the world by caching content at edge locations closer to the user's location. It provides seamless integration with AWS services and custom applications. It can also be used to hide origin information. So let's move on to the next service, which is Lambda. Here it's not a mathematical function, but a service provided by the AWS. So AWS Lambda is a serverless computing service that allows developers to run code without provisioning or managing users. With Lambda, developers can focus on writing codes and deploying applications without worrying about infrastructure management. AWS Lambda enables developers to build scalable, event-driven applications with minimal operational overhead, making it a powerful tool for building modern cloud-native applications. So these are all the services we will be conducting reconnaissance on using various tools and techniques. So now let's proceed to the next segment, which involves exploring publicly available URLs. So these are the services which you can see here. We have public URLs for them. This service comes with publicly accessible URLs. As you can see here, for EC2, we have a structure like EC2 public IP here. For S3, we have two type of structures. In the first, we have the bucket name .s3.amazonaws.com, and you can also add the object key here, which will be present in the bucket. Next, we have the other structure of the S3 bucket, which is bucket name .s3 website with the region .amazonaws.com. Next, we have CloudFront. For the CloudFront, we have some random ID .cloudfront.net. And last, we have SSO, which is single sign-on. For this, we have company name .awsapps.com. So you can conduct various web-based searches using tools like Shodan and Census on it. Alternatively, you can also utilize Google and GitHub Docs to gather more information via these URLs. So from this point onwards, we are diving into the exciting part. We will explore various tricks and techniques for performing reconnaissance. I will demonstrate ways to gather extensive information using web-based tools, CLI-based tools, docs, and many more strategies. So let's kick off with our first service, which is EC2. We have already covered EC2 and its tasks. Now let's delve into the gathering part, like gathering publicly available information about EC2. We can identify publicly accessible instances through tools like Shodan. Here you can see some of the Shodan queries to gather information about EC2. So let me give a quick intro kind of thing for Shodan. Shodan is a search engine that allows users to find specific types of computers, devices, and services that are connected to the internet. Users can search for Shodan's database using specific filters to find devices based on the criteria such as location, operating system, open ports, and more. So let's start with the queries. In the first Shodan query, we have two important components. First, we have this org the Amazon that stands for Amazon. This particular field restricts the search result to devices or services associated with the organization only. In our case, it is Amazon. Next, we have ssl.cert.subject.cn. So it filters the search result to devices or services where the common name field of the SSL certificate subject matches the specified organization name. So let's just try this query. Give me a second. So here you can see some of the outputs we are getting by running this query. So you can look for your desired one. You can gather much information from here. You can go to the link as well. You can check the services offered by it, the country, the origin, the cloud region, some of the open ports here. So you can gather many publicly available information from this tool. So let's move on to the second query. Uh, Give me a second. So the second query aims to identify devices within a specific IP address range. So you have to add the netblock range here, which are associated with the specified organization based on the SSL TLS certificates. So this, like for this query, this net part is the main field, which specifies the IP address range to search within. Second part is similar to our first query only. And the last query aims to identify internet connected resources such as servers or devices that are associated with the organization. In our case, it's Amazon, based on their host names. So next tool we have is FOFA. So FOFA is also a search engine that specializes in indexing internet connected devices and services. It allows users to search for specific devices, services, or vulnerability across the internet using a variety of filters and search criteria. So the first query filters AWS related information. This is the first query here. Uh, so let's discuss what are its fields do. So first of all, we have here body equals to AWS. So it simply targets services associated with the AWS. Next, we have protocol equals to SSH and protocol equals to RDP. So it includes services that use either SSH or RDP protocols. Next, we have this region. So you have to specify the AWS region you want to search for. And the last part is the ports part. So here we have mentioned the port number for the SSH and the port number for the RDP. So just sorry. Uh, so we have the other queries as well. So the second query also provides the same AWS related service based on specific criteria. But here we are specifying components like title. In title, we will be searching for the SSL certificates. And the third, we are searching for the Apache in the title. So now let's move on to the next service, which is S3 bucket. Unlike EC2, S3 presents numerous opportunities due to abundance of publicly available resources. So in this, let's start by Shodan. So the first Shodan query aids to identify web pages with the specified title AWS S3 Explorer. This could be useful for reconnaissance or analysis purposes related to AWS S3 Explorer. Similarly, in the second Shodan query, we are searching for Amazon Cognito Developer Authentication Sample. This can significantly help in gathering information to progress further. We also have FOFA queries here. So the first FOFA query is similar to the first Shodan query. Here it filters results based on the application or services identified as Amazon S3 within the search engine's index data. And the second query is designed to search for HTTP responses that contains the specified phrase list bucket result in their body. Let's move on to some other tools to gather more information regarding S3. So we have here some CLI based tools. First in the list we have CloudNM. So the CloudNM is a reconnaissance tool designed for enumerating various resources and services within cloud environment, specifically focusing on AWS. It aims to identify and enumerate AWS resources such as S3 buckets, EC2 instances, IAM users, and many more. By leveraging techniques like brute forcing, dictionary attacks, and API enumeration. So to use this tool, you need to install it first. You can like search for the installation part on Google. So this tool has some important fields as well, as you can see here. So first field is cloudnm.py. This specifies the path to the cloudnm Python script that is being executed. Next, we have -k option. It specifies a keyword or search term to be used during reconnaissance. As we are searching for AWS, we don't require searches on Azure and GCP. Therefore, we have disabled the Azure and GCP part. Let's try this command. So to save time, I have already run this command. Just a second. Yeah. So here you can see I have run the command and I have entered the keyword as security. And we are not searching for Azure or GCP. That's why we have disabled these cloud providers. So it will start searching for some of the S3 buckets and some of the AWS apps. And it has found some of the apps related to our keyword. So you can see the list of the AWS apps related to the keyword. So in the next search, I have searched for the atomic keyword. You can see the list of the AWS apps related to the atomic keyword. Again, uh, so next tool in we have in our bucket is S3 scanner. The S3 scanner tool to search for S3 buckets based on a specific keyword. So here we have S3 scanner script in the front of the command. Then we have dash bucket. There we have to enter any keyword related to the bucket name. It will search for that keyword in the bucket's name. Next, we have dash enumerate option. This option is used to enumerate the identified buckets. And the last we have dash JSON. This is to output the results in the JSON format. We also have some other tools like bucket loot and AWS bucket dump to do the similar kind of tasks. Next, we have some web-based recon. Firstly, we have several online bucket search websites at our disposal where you can search for bucket names. Some examples include Grey Hat Warfare, built with S3 browser, and many more maybe there. So let's simply try one of it. So this is the interface of the Grey Hat Warfare public bucket search website. So in this in this website, you can search for the AWS services, Azure services, GCP services, and DigitalOcean spaces as well. So you need to just enter the keyword here, let's say security, and just hit the enter. You can also add many more additional filters from here, but for making it simple, we are just searching for a keyword here. Yeah. So here you can see you can get ample of search results for the particular keyword. You can concise your searches by adding more filters to it. You can go to the bucket as well. You can search for more things inside the bucket. Yeah. So that's it about the gray hat warfare. Uh, We can also utilize some of the dogs here. We can utilize GitHub and Google Docs to further explore S3. So let's see more Google Docs here. You can see some listed Google Docs here. We can try one or two out of it. Give me a second. So here you can see this particular doc can search for all sites that have the index of followed by a bucket name in their title. You can search for your desired ones for as per your preferences, as per your search criteria. We can try one more. Let's just copy this one. So here you can see this doc can search for Excel files containing some passwords in it. With some luck, you might stumble upon some critical information as well. So next we will be initiating reconnaissance on EBS service. So here we have some FOFA queries you can see. So the first FOFA query aims to identify AWS related services where the HTTP response body contains references to EBS and size to the 100. This could be useful for reconnaissance or analysis purpose related to Elastic Block Store volumes with a size of 100 GB in the specified AWS region. In the second query, rather than specifying the size of the volume, here we are searching for a specified volume type. Here you can see we have mentioned volume type as GP2 in specified AWS region. You have to enter your particular region in this field. Uh, and the third query here is significantly important because it allows you to identify publicly accessible EBS snapshots within the specified AWS region. Here you can see we have mentioned public as true in our body. So through this query, you might get some publicly available EBS snapshots here. Next in our list, we have CloudROM Tool, as we have used for S3, like we can use for EBS as well. We can concise our search by adding some of the keywords here. It will work similarly as we have seen earlier. We can also employ some docs to gather more information about publicly accessible EBS. This doc, as you can see here, can search for AWS EBS on GitHub as well as Google. This approach can assist in gathering information from public blogs and repositories. You can also use other public blog websites as well. Next, we will be performing reconnaissance on RDS, which is Relational Database Service. So the showdown on the top, showdown query you can see on the top is very crucial as it enables access to databases through specific searches. This query can be helpful for identifying databases hosted by Amazon.com for further analysis or recognition purposes. This query consists of three important components. First component is the product, specifying the type of the database. For example, In our query, we have mentioned PostgreSQL, but we also have MySQL, SQL Server, and other databases as well. The second component is the port, which is set to specific values for different types of database. So 5432 for PostgreSQL, 3306 for MySQL, and 1433 for SQL Server. And the last component is the organization name, allowing for targeted searches within specified organization. In our case, we will be searching for the Amazon.com. So let's just try it out. So here you can see we have get some outputs for our query. You can check, like we can check one of this. So you can see the cloud provider is Amazon, as we are searching for the Amazon only. You can see for the cloud region, country, origin, uh, some some of the open ports here, and this particular file, like particular thing, is working on Postgres SQL. You can also check vulnerabilities associated with this particular service. Yeah. So in this, we have some FUFA queries as well to search more about RDS. We can conduct reconnaissance using FOFA. So the first query is designed to search for RDS instances within a specified AWS region. The second query is tailored to specifically search for the RDS instance running on MySQL within the specified AWS region. And lastly, the final query aims to identify publicly accessible RDS instances. We can also use docs for gathering more information regarding RDS services. So this doc can be employed to search for AWS RDS databases on GitHub or Google. This method proves helpful in collecting information from public blogs and repositories. We can also utilize CloudROM as we have already used for EBS. The process is similar. You just have to concise your search by selecting the proper keyword for it. Let's proceed with some techniques for AWS ELB service. Starting with Shodan, we have some queries here, some Shodan queries here for ELB service. So the first query's aim is to find instances or services related to AWS Elastic Load Balancer within the AWS Cloud provider. This query comprises of two components. First, we have cloud.provider. So this component filters results to include only product labeled as AWS ELB, which stands for Elastic Load Balancer. And the second part is the product. So here you have to mention your search for the product. The second query instructs Shodan to search for HTTP responses where the set cookie header contains the value AWS ELB. And lastly, the third query instructs Shodan to search for some HTTP responses where the location header contains the value as elb.amazonaws.com. So next we have Census. It's a search engine that provides a comprehensive view of the internet's networks and devices. Working of Census is a kind of similar to Shodan only. It collects data on hosts and websites through daily scan of the IPv4 address space, as well as by continuously monitoring IPv6. Uh, Also the DNS and the certificate transparency logs as well. So let's see the first query here, which targets HTTP response that contains the set cookie header with the value AWS ELB, and where the autonomous system is identified as Amazon O2. Here you can see. Additionally, it filters results labeled within a specified keyword. And the second query searches for the DNS names that contains elb.amazonaws.com. This indicates that the query targets hosts that are part of the ELB service hosted on AWS platform. Next, we have FOFA. Here you can see the list of FOFA queries. So the first query is designed to search for RDS within a specified AWS region. Second query is to get the DNS names along with the RDS information within a specified region. And the last query searches for some SSL certificate ID along with other RDS informations. Now we will be performing some of the recon techniques on AWS Cognito, starting with the showdown. So we have listed two queries here. So the first query searches for DNS names that contains aws.cognito.signin.user.admin. This indicates that the query targets hosts that are part of AWS Cognito services hosted on AWS platform. In the census query here, you can see that aws.cognito.signin.user.admin refers to the admin user role within Amazon Cognito, a service provided by the AWS for user authentication and authorization. Next, we have FOFA queries here. So with the first query, we can search for some publicly exposed components of Cognito, especially focusing on the user pool. Similarly, the second query targets the identity pool, and the last query is designed to identify domain names associated with the Cognito services. So moving on to our next topic, which is CloudFront Recon. Indeed, we will be continuing utilizing the search engines like Shodan, Sensis, and FOFA to gather valuable information about AWS CloudFront. These tools provide insightful details regarding the configuration, deployment, and potential vulnerabilities of CloudFront distributions. So let's start with Shodan. So the Shodan query instructs Shodan to search for HTTP response where the user agent header contains the value Amazon CloudFront. When we are sending this request to Shodan, it typically includes a user agent header to identify Amazon CloudFront. Next is the census query, which aims to identify targets where HTTP response contains the header key, indicating potential usage of CloudFront, and it further filters the result based on a specific keyword search. We can also search for cloudfront.net to gather more information as this is the public URL for everyone. So next we have FUFA queries listed here. So the first query targets instances or services related to AWS that contains the term CloudFront and distribution within the body of the HTTP response. So the provided query helps identify resources on endpoints associated with the CloudFront distribution. The second query is to search for the origin domain name, yeah, and the last query is to search for some SSL certificate IDs in our searches. Now let's shift our focus to another service, which is AWS Lambda. So our first tool we are using is FOFA. So the provided FOFA query is tailored to pinpoint instances or services related to AWS that features the lambda, features the terms lambda and function name here within the body of the HTTP response. The goal of this query is to locate resources or endpoints associated with the AWS Lambda functions. So the first and second query are quite similar. The only distinction in this query is first is searching for the functions, and now we are searching in the second one. We are searching for the runtimes respectively. We can also take help of docs to search more information related to Lambda functions. So you can see these are some of the docs mentioned. The first doc is intended to search for YAML files named as serverless, containing some functions within them. Then we have this second doc, uh, which is searching for some credential files. If you're lucky, the credential file may contain some AWS access keys and secret key access. The last doc we have aims to search for YAML file containing some IAM role statements within them. So now we have some Google Docs as well here. So the first doc is to search for some keywords related to Lambda. You can write some Lambda functions in place of keyword, as you can see here we have did in the second query, but for the Stack Overflow side. You can do same for the GitHub repository, but here we are adding ARN of the Lambda function. So you might get curious, what is ARN? So ARN stands for Amazon Resource Name, serving as a unique identifier for each resource within AWS. ARNs are crucial for identifying resources like EC2 instance, S3 buckets, Lambda functions, IAM roles, and many more within AWS ecosystem. Let's move on to next part. So as we move into our final segment, here let's explore some unauthenticated enumerations. This is where we uncover crucial findings like publicly accessible S3 buckets, EC2 instance, AMIs. Additionally, we may discover publicly accessible EBS and RDS snapshots here, which can be copied and attached to the instances for added benefits. Let's kick off to this section by focusing on EC2 images, which are known as AMIs, Amazon Machine Images. We will be searching for some publicly accessible images within our Amazon AWS account. Interestingly, for this section, we won't require any victim's credential or external access. Instead, we will be logging into our AWS account and conduct the searches. To run AWS commands, you will need to install AWS module for your command line tool. Once installed, you will be able to execute the commands seamlessly. Or you can also use console CLI. So the first AWS CLI command is employed to describe Amazon machine images that are executable by all users. So this command retrieves information about AMIs that are accessible to all AWS users for launching instances. So this command consists of two important components. One, we have describe images, and next we have executable users. So the describe image component retrieves information about AMIs, which act as template for creating virtual machines. And the executable users, this option filters the AMIs based on the executable users. By specifying all, it indicates that the command should return details about AMIs that are publicly accessible and can be launched by any AWS account. So we have a second query, which provides the same result, but here we are narrowing our search by specifying the owner ID. So here you have to mention the owner ID. And the dash query option selects only the images where the image location contain the specified Amazon, specified Amazon account ID here. The last query also yields the same result. Here, once again, we are narrowing our search by focusing on the images marked as shared. So the dash query option you can see here selects only the images where the image location contains the keyword shared, indicating that the images are marked as shared. This AWS CLI command is employed to describe AMIs that are publicly accessible to all users within the selected AWS region. As depicted in the screenshot, it lists all the snapshot IDs. The command has two important components. First is the region. You have to specify the region for the search. And second query is the second part is the dash query. So this option extracts the image IDs from the output. Additionally, due to the dash output option, as mentioned table, we are getting the snapshot IDs as presented in the tabular format. This command here you can see ensures that the selected image has public launch permissions, as evident in the screenshot. After executing the command, we receive an output of true, indicating that the selected image has public access. Conversely, if it returns false, it means the selected image does not have public access. In this image, we need to specify the region and the image ID. As we have collected the image ID from our initial searches. And the dash query option extracts information about whether the AMI is marked as public or not. Now let's move on to our next service, which is S3. Here we are conducting reconnaissance to identify publicly exposed S3 buckets by examining access control list configurations. First of all, we will list all the buckets available in our AWS account. So this command will do this. Yeah, this command will list all the buckets present in your AWS account. The command comprises of two key components. First, we have is list buckets. So this command lists all the buckets in your Amazon S3 account. And second, we have is the dash query option. It filters out the output to extract only the names of the buckets. This command right here, you can see, is used to describe the ACL configuration set for the public access grantee available for the selected S3 bucket. In this command, we need to specify the bucket ID or bucket name. As depicted in the screenshot, after executing the command, we receive ACL configuration set here as an output. In this ACL set, we can see the permission is set for the full control, indicating that the selected bucket is publicly exposed, which is not secure and compliant as well. Critical information can often be discovered through S3 buckets. It is possible that our organization may have stored some sensitive data and forgotten to adjust the access policies. Mistakes can happen as anyone can make errors in configuration or oversight. So let's just begin the demo by logging to our AWS Management Console. So here is my Management Console right in your front. First, we'll be using the CLI Cloud Cell given by the AWS. And just a second. First of all, let's list the buckets which are present in my AWS account. Through this command, you can list all the bucket names here. Now let's just check ACL for one of this buckets. To check ACL configuration set, we need to add this particular command here. Sorry, just a second. We have to mention the bucket name here. Let's try with new 1001. So yeah, we got the ACL configuration set. Here you can see the permission equals to full control, means this particular bucket is publicly available. Now, by searching on some blogs and some websites, I stumble upon one uh, bucket which has public access. So let's just try to copy the contents of that bucket into our bucket. So I'm trying to copy the contents of that bucket into the new 1001. So for that we need a command. So the command is this. So the command is sorry. So the command is AWS S3 CP, and you have to mention the source bucket URL here with the file with the object name. You have to copy, and then we have the destination bucket here. So let's just write the source bucket name, and here we have to mention the destination bucket URL. So we'll be using new 1001, and we have to just hit the enter. And as you can see, we have successfully copied the file or the object from resource box to our bucket new 1001. Let me show you. Here you can see we got the credential.txt file in our bucket. So yeah, this is the whole demo you can do for the S3 buckets. You can gather much more information from the publicly available S3s. Next, in our list, we have EBS snapshots. So an EBS snapshot is a backup of EBS volume at a specific point in time. We will be searching for publicly accessible images within our own AWS account. To do so, we don't require victim's credentials as mentioned earlier. Instead, we will be logging into our own AWS account and conducting the search. So the first AWS CLI command here you can see is employed to describe some snapshots that are executable by all users. This command retrieves information about AMIs that are accessible to all AWS users for launching instances. So the second command provides the same result, but this command specifically filters snapshots that are restorable by all users, as we are mentioning this field dash dash restorable by user IDs and putting the all here. This can provide details such as their IDs, volumes, status, and other relevant information as well. Similarly, the third command here yields the same result, but here we are narrowing our search by specifying the region and the owner ID. As depicted in the screenshot, it lists all the snapshot IDs. As you can see here, we have the result output here. This command has two important fields. First, we have dash filter option, dash dash filters option. It filters snapshot to include only those with a status of completed, as we have given the status for the completed only. And second, we have dash dash query option, which extracts only the snapshot IDs from the output, which has public access. Additionally, due to the dash dash option, dash dash output option, the snapshot IDs are presented in a tabular format. So this is the command where all the real work is happening. So this command ensures that the selected EBS snapshot is publicly accessible. As evident in the screenshot, after executing the command, we are receiving an output of group for all, indicating that the selected EBS volume snapshot has public access. This command has two important components. First, we have dash dash attribute. So this specifies the attribute to be retrieved, which in this case is the create volume permission. And second, we have query option, which extracts the create volume permission from the output. Next, we have some selected EBS snapshot to check whether the snapshot is encrypted or not. To do so, we have to run this particular command in CLI. We need to specify AWS region here and the snapshot ID here. So the command's crucial component is the dash query option, which extracts the encryption status of the snapshot from the output. As you can see in the screenshot, after executing the command, we receive an output of false, indicating that the selected snapshot is not encrypted. Conversely, if it returns true, it means the selected snapshot is encrypted. Let's move on. Yeah. So the first command here you can see retrieves detailed information about the instances tagged with the name. Here you have to mention the name. This includes essential details like the availability zone, instant ID, snapshot name, and many more things. Now, after getting the information, the second command creates one new EBS volume using the provided snapshot ID. Okay, so through these commands, we have attached this snapshot and instantiated it as volume within our account. Now, after attaching it to the volume, we have to attach the volume to our EC2 instance. So the first command here you can see attaches a specified EBS volume that we have created just now to a specified EC2 instance as a block storage device. Here we need to provide the volume ID here and the instance ID. Uh, for this command, the particular attach volume field is important. So this field is used to attach the EBS volumes to the EC2 instance. And we have dash dash device option here, which specifies the device name to use for the attached volume on the instance. We have to replace these dash backslash dev backslash sdh with the desired device name. The second command here is used to view the instance we just created now. As of now, we have completed our whole work, and to view that we have successfully done or not, we have to use this command to view our EC2 instance. By executing these commands, we have effectively replicated a public snapshot and instantiated it as an instance within our AWS account. This grants us the ability to utilize it for our internet purposes. Let's move on. So our next service is the RDS snapshots. In Amazon RDS, a snapshot is a backup of DB instance, including its data configuration and metadata at a specific point in time. So we are now at the final stage of our reconnaissance journey, where we will be performing reconnaissance using CLI commands to identify publicly accessible RDS database snapshots. All this will be performing is on our AWS account only. So the first command here you can see is employed to list all the RDS database snapshots available in our AWS account. The command's important component is the describe DB snapshot, which retrieves information about all the RD database snapshots. The second The second command here you can see is to check for the describe DB snapshot. You can see this is to check for the snapshots with the snapshot type as manual. And also we are including public. We are searching for some publicly available RDS DB snapshots in our search. So next upon list we have the third command, which retrieves information about the RDS databases uh, in the specified AWS region. Additionally, due to the dash dash option, dash dash output option, we are getting all the snapshots ID in a tabular format. Here you can see as depicted in the screenshot. In the second command, you can also choose for some other snapshot type as automated and AWS backup as well. So next, we can also see the selected RDS database snapshot is encrypted or not. To do so, we have to run this command. And we need to specify the AWS region and the RDS DB snapshot identifier here. So the dash dash query field is very important for this command as it extracts the storage encryption status of the snapshot of DB instance from the output. As you can see here in the screenshot, after executing the command, we receive an output of false, indicating that the selected database has publicly available snapshots. Here you can see attribute values to all, means this particular snapshot is accessible to all users. Okay, so now we will be restoring this database snapshot into our account. So this command here you can see is to like restore the database into sorry, just a second. Yeah, yeah. So this command here is to restore the DB instance into our account. So a restore DB instance from DB snapshot is the main field here, which will be doing all the works, and the dash dash publicly accessible flag indicates that the restored database instance should be publicly accessible. The second command is used to access the database we just recovered now. So through this we can recover the database into our account. And here you can see the first command, which is modify DB instance. This command is used to modify an existing RDS database instance. We can modify or reset the master credential of this restored database. So all the work done is done by the modify DB instance, which helps to modify settings of the database instance. Master user password field here you can see is used to change the password of the database, and does apply immediately. Here we are using to make modifications immediately. And the second command here we have in our deck is used to check the instance is successfully restored and working fine. Through this command, we can ensure that our whole work has been done and we have successfully restored the particular publicly accessible RDS snapshot into our account. So as we are at the conclusion part of our webinar, I like to share some more information, more important information. So this webinar is a part of a series, and we will also be setting up some more sessions on Azure and GCP in the future. As of now, to continue this journey, you can opt for the MCRTA certification offered by the CyberWarFare Labs. So this certification is designed to cover all the major cloud service providers, and it is uh, uh, completely beginner friendly. If you are interested in exploring the cloud, this certification is for you. Thank you for everyone. Thank you everyone for this part for your participation. If you have any question, please feel free to ask. Yeah, okay, guys. If you have any question, you can ask now. Questions are here. Okay, okay. So for scanning Dockers containing containers, you can search for to search AWS containers. You can go to some public blog websites or some docs. You can also use tools like Shodan. Shodan is really a good tool. You can gather much more information from that. Okay, okay. This work if we didn't provide. Yes, yes. You don't need to provide any CLI like credentials to anyone. Like you need to just log into your account. We are doing these things from our account, so we don't need any credentials or like victims credentials to do so. Yeah. So like Sheikh Mohammed, what type of logs generated in it is, can you like elaborate more on it? Yeah, yeah. The recording and the slides will be there in the Cyber Warfare Lab website. So you can visit cyberwarfare.live, and in the blog section you can find all the things like in just 24 or 48 hours, and you will also be receiving one mail for all the recordings and the documentations. So this part is like for the initial access, initial thing. From this onwards, you can go for the MCRT certification. Yes, you can get some of the insight of this thing as well, and some of the more unauthenticated enumeration will be there. Some of the authenticated enumeration will be there for you guys. Yeah. Yes, yes, you will be getting all the materials, Daniel. You will be getting all the materials. Or you can just visit the website cyberwarfare.live. You can get all the things in the blog section. Yes. I guess not, because you are the owner of AWS account. So you are doing this commands and all in your account. So if you have selected the option, you might get the logs, but you will be doing that thing. Okay. So you are not performing anything in the victim's account. You're performing in the in your account only. Okay. So for the certificate of attendance, you will be receiving one mail. Maybe within 24 hours, you will receive the certificate. Yes, for every service, there can be specific docs. You can also create your own doc by making some fields, like by changing some fields. You can do lots of things with the docs. You can concise your search by adding some more parameters like in title, in URL, in your doc. Yes. Okay, so we will create some cheat sheet for you guys. Like in for upcoming webinars, there will be some cheat sheets as well, and you will also like we'll try to make some cheat sheets for the AWS as well, and try to revert back to you. Yeah. Okay. Yes, yes. You can see publicly available buckets on internet. You can go for the some search search tools, public search tools we have mentioned, Grey Hat Warfare and any other tools. You can also uh, search through docs. You can go with the commands, CLI commands. We have like much more things for S3, many things for S3, because S3 is the service which you can find publicly for everyone.